How do we know if a claimed decipherment is true or false? Is it forced or is it natural and correctly done? Let us try to answer this question today. First, we have to distinguish between a language and a script. A spoken language is a set of strings of auditory symbols. So we can create a word called dog, and as long as you and I agree what it means, then that exists as a word in our language. A written language is a mapping of spoken language to visual symbols. And this translation is usually lossy and has ambiguity. There are different kinds of ways to write language and different rules on how to do it. Alphabetic is something that you're familiar with in the English language. There's also syllabic, abjad, which is used in Arabic, Hebrew, and some Semitic languages, and logographic, which would be something like Chinese. The sequences of sounds or words in one language are just random noise in a language B. This is why when someone speaks in a language that you are not familiar with, you cannot pick out any words, you cannot make out any meaning, because the sequences of the sounds that they use to create words and the sequences of words they use to create sentences, they are completely random in your language. If we try to map one language as another, we would essentially be mapping a set of auditory symbols into a common orthography or a common set of visual symbols. So, normally, what would happen is that if you do such a map, the chances that the sequence of symbols that are words in one language is also a word in another language is going to be low. And what you have to do is you have to maximize the chances, and you can do that by sorting the symbols by their frequency. So that way, the most frequent symbol in one language is mapped to the most frequent symbol in the other language. This increases the chances that a symbol is next to another symbol in both languages. Therefore, your chances of getting unreadable words decreases a little bit, and your chances of creating readable words increases a little bit. You can visualize this by looking at a grid of symbols in any language. Here we have English, and we have words that are 2 letters long. And as you can see, most of the grid is empty. There are no words because combinations like FG, RK, etc. are not words. The words cluster around vowels. So the columns and rows that have vowels have words, and generally, even then, most of the grid is empty. So most combinations of symbols are not words. So the word space, therefore, is sparse. And as you grow to longer and longer words, it becomes more and more sparse. So, for example, there are approximately 4,000 common words in English out of a possible almost 12 million combinations of 26 letters times 5. So, the probability of a random sequence of symbol being a legal word is very, very small. In addition to um, just the long words, even sequences of two symbols being next to each other is also very unique. So in English, for example, TH is a very common sequence, and whatever you map it to in some other language, it may not be that frequent. The probability of a word from a set of symbols that you mapped being in one language, if it's less than 100%, it is more than zero, and the probability of the word being in another language is also similar. So the probability of any sequence being in both is the product of these, and because both of these values are less than 1, it becomes much less than 1. The probability for all the words that you mapped to be in both is the product of all of these, and it is essentially close to 0. So for a small text, you can force fit a language of your choice, but for a large text, it's not fitable. Now, this is for an alphabet. What happens when you use a different orthography? For example, in syllabic, because every symbol also has its own vowel, you have now selected only those rows and columns which have uh, vowels in it. So you avoid the issue of the alphabetic where you have multiple consonants or multiple vowels coming next to each other, forming impossible sequences. Whereas in syllables, you can you have a more natural sequence of syllables and vowels that you can try to create words. But it will be very hard to create many legal words. Some of these sequences will not be words in your language. Syllabic has many forms or many related orthographies. One of them is Abugida, which you find in India. Most Indian scripts are Abugida. And there's Japanese More, which is also a kind of syllabic. And these are the primary syllabic scripts that you know about. There are also other syllabic scripts where there is consonant, vowel, consonant. Coming down the line, when things get a little more easier, is if you have an abjad. So in an abjad, you don't really have vowels, or rather vowels are optional. You can pick certain consonants and treat them as vowels when they're convenient. So the sequence of letters here, you can see BK, FLT, and so on. You cannot really read it, but in an abjad, since you just insert vowels as you want, you can read that as a book fly to jungle lane, or break full, something like that. You can try to force reading. Logographic symbols or scripts essentially assign a single word to a single symbol. So I have given this example of Egyptian hieroglyphics, which are not strictly logographic, but for sake of illustration, you could assign quail, owl, and so on. And the issue there is that those words often do not belong to each other if you map it from a different language. It would not be meaningful. You would not understand why these words are next to each other. Logosyllabic is a variant where you can choose to just take the a sound of that symbol, mix them together, and even use what's called a rebus. So rebus is when you don't have a word for an abstract concept, but you merge 2 or 3 such symbols and use their sounds to express it. So in this example, I could take the quail and the owl and create quill and claim that I have read it. So this is essentially where most decipherments of the Indus script try to focus on, logosyllabic, because this is the highest chances of getting a fit, being able to read something meaningful. My decipherment is Abugida. It's very, very difficult to fit anything with Abugida. So even with Abjad, it is relatively hard. But Abjad, if you treat every symbol as its own word, like if you have words for every symbol, as and when you get 2 or 3 symbols in a sequence to form a word, you can use it, but you don't need it. You're not constrained by it. So Abjad, logographic, logosyllabic essentially are easier. Logosyllabic with rebus and polyvalence is the most easy. Polyvalence is the symbol value changes based on what is next to it. So you can read that owl as something else if it's next to some other symbol. It gives you enormous flexibility on trying to create meaningful sentences. But even these, which most people have attempted, has been a failure. They're not able to read anything meaningful. So what happens is when you even if you can read every symbol as a word, the fact is you are reading, when you try to force fit something, you are reading a random string in the language you're trying to read, because the source language, the patterns in the source language are a random string in your language. So it is very hard to create anything meaningful if your language is incorrect. One alternative is to bring words from multiple languages and saturate the word space. So Kalyana Raman, who is been deciphering the Indus script for decades, uses this technique. He brings the words from all Indian languages and even Arabic and some of the other non-Indian languages. Tries to read a word, applies rebus to it, and tries to create a meaningful reading. The reason you get meaningless readings is that when you assign words to symbols, those symbols occur in certain patterns in the original language, which won't be meaningful in your language under your assignment. So for example, let's say we have symbols, like 4 symbols which we have assigned the values dog, house, wife, guest. So when you have combinations such as dog house, housewife, they make sense in your language because those patterns, those compounds, or those phrases have a mapping into your conceptual space in your language. But some other mappings, like guest dog, wife guest, they won't make sense because those combinations do not exist in your language. One way to deal with that, as we saw earlier, is something called polyvalence, where you say that if the symbols wife and guest are together, then it means in-laws, something like that. You just change the meaning entirely, and you can do this for many permutations of the words that are inconvenient. So let us look at some readings of different Indus script decipherments. And this particular one is by Mizuhiro Kuroda. He has deciphered the Indus script as Japanese. And as you can see, the readings do not actually make sense because the words do not belong with each other. O camel with horse ears. So this is not a sentence you expect in any literature of the world. Or with this first brother's household is. Fur and the brother and the household, they just don't belong together. Your brain will not find a place in its conceptual framework to place this phrase. So this is another one by Ramkumar Unnipillai, and here what he's done is he's assigned values to each symbol. So the first symbol, the leftmost symbol, is Kai, which is like a hand. Next is Nala, which is like 4, and so on. But when reading, as you can see, he reads it as par ayan valam. There's no V or Y in the reading, and he uses flexibility to insert them. So essentially, all of these really are sort of logosyllabic. This is another one where it is purely logographic. Every symbol has a word, and you just try to read that as a sentence. And again, these don't make sense because you don't expect these words next to each other. So for example, bearded merchant sells 2 pottery wheels and 16 fish. It's a good question. Why? What happens if someone wants to buy 20 fish? It is not a thing which you expect someone to write somewhere. Or if you see the M56A Bengal pottery mallet pincer next to 200 dry fish and rim jar in a fortified room, you don't expect these words together. So these decipherments need a little more work until they can consistently produce a lot of meaningful readings. This particular thing requires an honorable mention. This is from Twitter anonymous users Ugra Sravas and Prakash, who forced a Sanskrit reading of the US Constitution. And they did that by creating an abjad and ignoring word boundaries. So they would read the entire thing as a single stream, breaking it where convenient, breaking a word where convenient, even across actual word boundaries. And essentially, it also acts as a logosyllabic in the sense you can stop where you want, you can do rebus and so on. But it is notable because it has very few grammatical errors. But as you can see, it is still meaningless. Pick anyone, superior, goer, movable, secretion of clay. It doesn't, none of these words belong with each other. Or the last one there, elephant joint, bamboo strings on the bridge, none of those words you don't expect them together or have any kind of meaning to be associated with them. Now, coming back to meaning, what exactly is meaning? When you see a set of words, even if they are completely, on different lines, you can infer meaning out of them. So here in the second and third list, you can infer that this is the recipe or a shopping list. But if it's random, you won't understand what it is. That is similar to these readings. You don't expect these set of words next to each other. So hence you're having a problem understanding the meaning because these are essentially random sequences of words precisely because they are sequences in a different language. They're not sequences in the language in which the values have been assigned. So what would a proper, meaningful reading look like? So this is a Sumerian cuneiform, and you can see it reads 60 liters of barley for this person, 20 liters for someone else, and so on. And even though it is just short, you can see the consistency of themes. It is a quantity of something for somebody. So if you see these, you know this is a kind of a ration distribution list. And similarly, when you see other decipherments, you will see that there are many such ration distribution lists, and therefore they will form a consistent pattern or consistent conceptual or thematic view for you to understand what they are writing, and that is how you know that this is a proper reading. So let's look at my decipherment. So on the left column, you see completely different symbols in each row. They're nothing like each other. They create words that are also very different from each other, right? So Prarava is different from Bhanavi and so on. But their meaning is consistent. They're talking about a roarer, which is Rudra, and it is very hard to create consistency in that way accidentally. From randomness, you are not going to get uniformity. The second thing you will also notice is the different declensions and the different morphology for the same word. So here we see Ravam, which is accusative, Ravavan, which is it's a Tadita affix, and so on. So Ravasya at the bottom is possessive, it's genitive. So when you see different symbols that are assigned completely independent values and they converge on the meaning, then your decipherment is likely to be correct. So, in summary, the mapping of the letters does not remove the randomness of concepts. So, this is how you can know whether a decipherment is right or wrong without having to worry about information theory or anything else. Good decipherments have good grammar, proper morphology, and most importantly, they have consistent themes. Bad decipherments are mangled words, no grammar, and most importantly, they have inconsistent themes. They do not have words that go together. That is the sign of forcing. So, this is how you can look at any decipherment and very quickly get a sense of whether this is forced or not. With that, we come to a close. Thank you.